one thing you should be familiar with is the concept of an imaginary number, and we usually use I as a stand-in for this, the square root of -1. The thing we're not allowed to do because it produces imaginaries. Well, we just say, fine, square root of -1 is a thing. It's going to be symbolized by the letter I. And what are all these other things, right? What is I squared? What is I cubed? And so on. And in this problem, it says, what's the sum of all this stuff? So this could get pretty complicated if you don't know some basics about the way exponents work with imaginaries. Well, if you imagine I squared, what is that? That's just I times I. And what's the square root of -1 times the square root of -1? So it's going to be -1. The square roots wipe out. When you cube something, what is that? That just means I times I squared. Now, we've already established that I squared is -1, so this one is -I. And I to the fourth, well, that's I squared times I squared. -1 times -1, +1. And I to the fifth, well, that's just I times I to the fourth, right? I to the fourth is 1, so this becomes I. If you see what I'm doing here, I'm writing all of these I squareds, I cubes, and so on in terms of either 1 or I with a plus or minus sign. And now if we keep going through this, I to the sixth is equal to I squared times I to the fourth. I to the fourth is 1, I squared is -1, so the result is -1. Look at this. This is a repeating pattern. The next thing it's going to be is -I, then it's going to be +1, then it's going to be -1, like that. I'm sorry. +I for I to the ninth. Okay, so there's one thing, and you should be able to quickly establish what I squared is, what I cubed is, and so on. That's not the quickest way through this problem. The quickest way through this problem is realizing that I squared and I to the fourth have opposite signs, but are otherwise equal, meaning they cancel out when you add them together. So those guys are going to cancel out. Let's see what else cancels out. I cubed and I to the fifth. Look at these. -I, +I. Those are going to cancel out. Okay, I to the sixth and I to the eighth. Those also have opposite signs. And, oops, I want a different color here. I to the seventh, I to the ninth. Those also cancel out. Those have opposite signs. So these things in this particular problem happens to all cancel out so they equal 0. That won't always happen. Sometimes you'll be left with a 1 or a -I or something like that. But when you're adding up a whole bunch of these things, remember that sometimes they simplify quite nicely. And if you understand the rule of exponents and how those work with imaginaries, you can find your way through the problem quickly.